All right, class, as you can see today on the video, we're going to finish up linear equations in two variables as far as the introduction part. Still got to do some slope and some different things there, but definitely want to get the basics down. We've graphed them using tables. We've graphed horizontal and vertical lines. Now we're going to deal with intercepts. Again, your background knowledge should apply a little bit here, but we're going to be able to graph equations, graph tables, graph different situations using the intercepts. We'll definitely work a lot on story problems as well. Just some background knowledge that you need to have. Make sure you need to have the definitions down. The x-intercept is the x-coordinate of the point where the graph of a linear equation crosses the x-axis. A lot of x's there. Basically, I want to know at what point does it cross the x-axis. And what you'll see, we will know the y-coordinate there, so we just need the x-coordinate. Vice versa, the y-intercept is the y-coordinate of the point where the graph of a linear equation crosses the y-axis. So as you see on this picture, we have the y-intercept and we have the x-intercept. So notice the y-intercept is where it crosses the y-axis. But very specifically, I just want the y-coordinate where it crosses the y-axis. So in this case, in this picture, the y-intercept would be the y-coordinate where it crosses the y-axis, and it crosses the y-axis at 3. And so in that case, the y-intercept of that line would be 3. Conversely, we have the x-intercept at 2, 0. We see that it crosses the x-axis at 2, and therefore the x-intercept is 2. One thing that I want you to make sure that you notice as you look at these graphs and you look at these pictures, we see that the x-intercept was 2, and we notice that the y-intercept was 0. Vice versa, we look at the y-intercept was 3, and then the x-coordinate was 0. And so that gives us a very important piece of information as far as how we find x and y-intercepts. To find the x-intercept, you simply substitute 0 in for y, because you know when it crosses the x-axis, y will always be 0. At the same time, to find the y-intercept, substitute 0 in for x, because you know when it's crossing the y-axis, x will always be 0. So for an example, find the intercept of the graph 3x minus 2y equals 6. If I wanted to find the x-intercept, I would need to plug in 0 for y. And so what that looks like in this equation, I'll rewrite exactly as I have it, but then I will put in a 0 for y. Every time I substitute, I put parentheses around that number, and now I'm just solving for x. I'm going to try to find what x is when y is 0, because whatever x is when y is 0 will be our x-intercept. In this case, what's nice about this method, that all falls out, and I just have 3x equals 6. To divide by 3 on both sides then gives me that the x-intercept would be 2. As an ordered pair, that would be 2, 0, but the x-intercept itself would just be x equals 2. If I wanted to look at the y-intercept, now to find the y-intercept, I substitute 0 in for y. And so, I substitute 0 in for x. And so I have 3 times 0 in parentheses minus 2y equals 6. I'm trying to find the y-intercept, so I know x will be 0. That goes away. Notice it's a negative 2y. I want to keep track of that. To solve for y, I need to divide by a negative 2 because I use inverse operations. And so notice y equals negative 3 at this point. That means we know that x was 0 and y is negative 3. As an ordered pair, it would be 0, negative 3. But the y-intercept in this case would be a negative 3. Why this matters to us is what we've been working on this week. We can actually graph these. So if I wanted to graph this equation, I could just use the intercepts. We now have 2 points that we can use to graph our line. We have 2, 0 and 0, negative 3. So I noticed that the x-intercept was 2, 0. And I know that the y-intercept was 0, negative 3. To graph this as a line, then I just need to plot those 2 points and then play a little connect the dots. The x-intercept, where it crosses the x-axis, so again, for my x-intercept, I know I'm going to be on the x-axis, and in this case, I'm going to be 2 to the right and then 0 up. That would be the x-intercept. For the y-intercept, notice I have to be on the y-axis. Don't go anywhere left or right, but I go down 3 because it's a negative 3. Once I've plotted those 2 points, in order to actually graph my line, I'm just going to connect my dots. Because it's a line, oh, nice job on the line, too. You know that went through the point. Just pretend it did. Because it's a line, I also know that I need to have arrows on both ends. One thing that you see when you compare this to the table, when you compare it to some of the other methods that we'll use, it's nice in that it only requires 2 points instead of 3. It's a little quicker. At the same time, it's a little more difficult to draw that line and to make sure you have an accurate line because you only have 2 points instead of 3. And technically, we always need 3 points for a line. That's all there is to the video today, just making sure that we understand x and y-intercepts, what they mean, how to find them, and then, of course, how to graph them. If you have any questions, we can use the discussion board to discuss. Otherwise, you need to have this ready to go in your notes by Monday.